Let's begin by discussing the truth value of this statement. If yesterday was Sunday, then today is Monday. This is a true statement. Remember last time we talked about different ways to write a statement. What if we turned this around and wrote the converse? How does the converse work? If, starting with the conclusion, today is Monday, and then we end with what was at the beginning, the hypothesis. Then yesterday was Sunday. Considering the truth value of this statement, if today is Monday, then yesterday was Sunday, that is also true. When a statement is true forwards and backwards, the conditional and the converse are true, then a faster way to write it is the biconditional. Bi, a prefix meaning two. It works two ways. So we say yesterday was Sunday if and only if today is Monday. Here are two ways to write it. Yesterday was Sunday if and only if today is Monday. Yesterday was Sunday if and only if today is Monday. This is just a way to shortcut write if and only if. But when you see that connection in there, it means it's a statement that works both ways. We can say it if yesterday was Sunday, then today is Monday, or if today is Monday, then yesterday was Sunday. So three important things to remember about a statement. One, it's a statement that is true both ways. The conditional and the converse are true. Second, the format. The way it is written goes hypothesis, or a statement that usually starts at the beginning, the words if and only if, unless we're using the abbreviated version for if and only if, which is IFF, and then the conclusion, or the statement that usually comes at the end, such as yesterday was Sunday if and only if today is Monday. The symbolic notation is with a double arrow because it doesn't just flow forwards to front to end, it flows both ways. It is true both ways. Let's take a look at an example. Write the converse of the statement. If the conditional statement and the converse are true, construct the biconditional statement. Then translate each statement into symbolic form using your own letters. 1. Conditional. If the sides of a triangle are congruent, then the triangle is equilateral. First, we are to write the converse of the statement. Remember, that means switch the order. So looking at the hypothesis and looking at the conclusion, the converse begins with that conclusion. If the triangle is equilateral. Notice sometimes I'll use symbols or abbreviations that are commonly accepted. If the triangle is equilateral, then, now I look at what was at the beginning, the sides of the triangle are congruent. Again, notice a commonly used symbol for congruent is the congruent symbol, so that's accepted. What's next? If the conditional statement and the converse are true, construct the biconditional statement. So let's look at the conditional statement. If the sides of a triangle are congruent, then the triangle is equilateral. This is the definition of an equilateral triangle. So this is a true statement. The converse, if the triangle is equilateral, then the sides of the triangle are congruent. Well, because we gave a definition, it will be true no matter how we write it. So this statement also true. If the conditional statement and the converse are true, we can construct the biconditional statement. So now we're going to do that. Remember, we take off the if and the then, and we connect the hypothesis to the conclusion with the words if and if. So we begin, the sides of a triangle are congruent, and then we put those words if and only if, or feeling free to use the abbreviation IFF, then the triangle is equilateral. Not using then, not using if, because that implies it only goes one way. Now let's pick our own letters to translate the statement into symbolic form. The sides of a triangle are congruent. Maybe we'll call that A. The triangle is equilateral. Maybe we call that B. So the conditional statement, usually in alphabetical order, A arrow B. Remember, converse turns it around, B arrow A, and biconditional goes both ways. Now, since it goes both ways, it doesn't really matter which letter we begin with. However, because I begin with the sides of a triangle are congruent, and that's the A statement, we do need to follow since we're translating that order. So double arrow and then B. Now it's your turn. Can you try to construct a conditional statement that is true both ways, such that it's true as a conditional statement and the converse is also true? If you can, then you can write the converse and then the biconditional and the symbolic notation like we did in the other one. Why don't you pause the video, give it a shot, and see how you did.